I think to round off this introductory particle course, let's put all of our knowledge that we've learned together and make this particle system that we have here. A particle system that is just like a laser with some impact particles going on. And the most wonderful thing about it is that it has this little widget that we can move around to change the endpoint. And the little laser here will stay like consistent in its amount of detail as the laser gets longer, and the particles here always spew towards the direction of the laser, which is quite nice. So this will work fairly nicely as like an impact on the floor, for instance. Now they are all spewing upward. Let's make this to put all our knowledge together and really put to the test how much we've learned throughout this course. And the way we're going to go about doing that is I'm just going to make this as one big system. You can make these as separate emitters if you want to. There's also the fact that when you have a system, I don't think we've talked about this yet, but when you have a system and you've changed the emitter in it for whatever reason, you can right click, you can create an asset from this emitter. So you can just make your system, and if you don't want to reuse an emitter from that system, you can still make an asset out of it to reuse in other systems. So let's just start by making a Niagara system. It's going to be an empty system, and we'll call this our laser impact. Let's do the actual laser bit first. So emitter update, what we're going to be doing is we will spawn burst instantaneous, and we're going to set up a beam emitter setup. For the time being, let's set the spawn count to something like 10. We're going to set this more programmatically in a moment. But first, I just want to add in all of the little modules here so that we have what we're going to be working with, and then we can start tweaking things a little bit. Particle spawn, of course, we have our initialize particle. Then I also want to spawn a beam, because we're going to be using the beam setup for this. Then in particle updates, we have our standard particle state, but I also want to jitter the position of the particle, which we've talked about. We'll do this, create like a noise offset for its position. And then let's also just set the color in here. I guess we can do it on spawn as well if we prefer. And instead of doing a sprite renderer, what we're going to be doing is we're going to be doing a ribbon renderer, of course. And that looks like this now, which is not exactly what we're looking for, right? So with all the modules created now, let's actually start filling them out. First and foremost, in our initialized particle, we're going to set this to 1/4 of a second lifetime, which will be a little bit better for us. And then in the system, what we'll do is we'll set the loop duration to the same amount so that we can more easily preview it. Now we can see it creates them over and over and over and over again, giving us a slightly more like real world look at how this is going to behave in our levels. Now, for the amount of particles that we're going to be spawning, I've set this to 10 at the moment. We're going to actually set this as a user parameter instead. So that's just going to be a common, which can be a float. I suppose it could even be an integer, to be honest with you, because it's going to be a whole number anyway. So let's do an integer. And this will be our spawn count. And by default, set that to something like 25. And that's going to be dragged on top of our spawn count here. That way we can set the actual spawn count on runtime in the actor that we're going to be making for this, because we're going to be making a specific actor with a little bit of extra code to make this work as well in a moment. And then while we're at it, making user parameters, we'll also make a new common vector user parameter, and this will be the end position. So by default, let's set that to like 200, 0. And we're going to be using that to set up our beam. So in the beam emitter setup here, and for the beam start here, we're going to just stick with simulation position for now. The beam end, of course, will be our end position that we just made. If you want to make something that, for whatever reason, can have a offset starting position as well, there's a little bit more math involved in all that. We're not going to go into that right at the moment, but that is possible. I'm just like referencing the thing that I made to prepare for this. And here what we're doing is we change the beam start to a add vector, convert position to vector, and then the input position will be the position of the particle system, and we're adding to that a starting offset value as well. Entirely possible. Again, that was just me messing about a little bit. For the most part, entirely unnecessary as well. Now let's go into our initialized particle right here. and I want to set my ribbon width to direct sets, and we're going to set that to a thicker value. Let's actually set up the color real quick here. So what we're going to be doing is I'll actually make a parameter for that as well. Let's make a linear color here, and that'll just be the color. Let's set the default value to like red or something like that, orangish. That's going to be our default value, but I actually want to multiply linear color by a float for the intensity. So we'll get our color here, put that in there, and then also add in a new float for the glow intensity, and let's set that to like 10 by default, and that's going to go in there. So now that color is going to get multiplied by the float, and because it's emissive, we get this. Maybe even like 20 as a default value. Maybe even like 50, honestly. Like, don't be afraid to make this quite a high value. Still doesn't look particularly great though, and that is because the jitter position is kind of off. First and foremost, the jitter amount needs to be way less. But also, we need it to be only jittering in the middle, not on the ends. We don't want the start and the end of this ribbon to actually jitter about too much. We've done this in a previous video, I believe, so I'm going to go over it pretty quickly, but we can get a jitter amount from curve, and instead of using the normalized age, what we'll do is we'll use the link order. So if we use the ribbon link order, we put in a curve that looks a little bit something like this, you can see it's only jittering in the center. Of course, what we'll actually want to do is we'll want to move this one as far to the left as is reasonable. We'll make a new key, which you can do by using the middle mouse click button. The key data is going to have a value of 1 in the second slot there, and then we'll pull that across as well. And now we can see over here, the entire thing is jittering except the beginning and the end. And now we can slowly start to scale up the amount of jitter. And maybe the spawn count's also just a little on the high side, to be honest with you. There's a little bit of experimentation needed here for getting good values, as is usually the case. Or maybe we want to actually have a slightly higher amount of particles which jitter less. That actually probably looks a bit better. And maybe we even want this one to be like closer to both of the ends, which you can just kind of mess about a little bit. Get this back to 1. This looks pretty good at this point, I would say. So now, if I change this end position to something like 100 units to the top, it starts going in that direction and so on and so forth. So we have a very easily editable like lightning strike at the moment. Now, for the next one, we're going to be adding another emitter, and we're going to be using the fountain as a base, just because it is kind of the easiest way to do this. So we start with this, which obviously doesn't look very good. We'll stick with the spawn rate of about 90 for now. I think that's pretty good. But we want to go into the shape location here, because the shape location we don't actually need. We'll delete that. We're going to be setting the spawn location for this in the initialized particle instead. As you can see, we can use the position mode, which is where the particle spawns to begin with. I'm cutting in real quick here during editing. In the setting position directly, you actually want to set this as simulation position, not as direct set. And then we use the offset mode for the end position. If you see anything else later in the tutorial, when we go back to initialize particle, ignore that. I kind of just selected the wrong thing. So I'm recording this after the fact to fix that. Now, for the velocity, it's just spewing upward at the moment, which is obviously maybe not great. What we want to do is we want to calculate the direction between the end position and the start position, because that is what the cone axis needs to be in our add velocity. So for this, we will get a subtract vector, and we're going to be subtracting the end position from the starting position. So we can drag in the end position here, and that will then be spewing towards 0, 0, 0 now. So no matter where we are, again, if we have this like very high up, you can see it is now spewing toward there. If we set this to like all the way over there, or maybe even in the negative, the other way around, it's always going toward the origin point. Of course, if you're using a start position value as well, you then put that up in the A slot for subtract vector here. Let's set these back to some decent default values. And that honestly is the hardest bit that we are going to work. And then in our particle update, we have a scale color here. We're actually just going to copy over the scale color from this one because we'll delete the one that exists so that they have matching colors. You can add a alpha fade out for these as well. What I personally prefer to do for these kind of like spark type particle effects is I just scale the size instead. So scale the sprite size and we just kind of scale those down linearly into nothingness. That just feels a little bit more like they're emitting sparks. For the gravity force, that's entirely up to you. I like making it a little less strong for these ones, so going down to like -500 maybe. So that there still is some gravity, but just not as much. And the same thing you can say with the velocity here. It's between 500 and 850. Maybe you want to set that to between like 300 and 900 instead. So there's a little bit more variance in there. Makes it feel a little bit more erratic, a little bit more like actual sparks flying all over the place. I think what's more important though is in initialized particles, setting the lifetime to something more reasonable, like 1/4 of a second to, let's say, 0.4 seconds. So they don't live as long, and suddenly that already looks a lot better, doesn't it? So actually set the end position to like 200 so that the laser is a little bit longer. And if you want to, you could increase the drag a little bit as well, so that they slow down a little bit more. Again, as they start to slow down and lose mass, is kind of what you're implying there. The drag probably would slow them down a little bit as well. Now, the most important thing to make this look better, to imply that they're like sparks, because right now they're just a bunch of circles, right? So if we go back into initialized particle real quick, we can see the sprite size mode is set to random uniform. We're going to be setting that to random non-uniform, meaning that they will be all sorts of shapes and sizes, and already you feel like this looks a lot better. So I'm going to set the minimum sprite size to like 1 and 1, and then the maximum to like 7 and 7 or something like that, which makes them so much more varied already. Maybe we can experiment with like 2 to like 9 or something like that. And the last finishing touch that really makes this work is going into the sprite renderer and saying the alignment, instead of automatic, we're going to be aligning them to their velocity. So now they always will align themselves in their rotation to their velocity. So they seem to like actually be moving around in the world and keeping their rotation and shape based on like that they're being given due to the non-uniformity of their scale. And that is effectively the particle system. So now let's make an actor to put this particle system in, to start driving some of these things, and we can actually put them into the world with that. So we make a blueprint class, just a normal actor. This will be our laser actor. And in there, we will add in a Niagara particle system component, which we'll just keep as Niagara. And we'll put in our laser impact here. And you can see we have all of our parameters that we had before are now exposed in here as well. So we can set the color to something different if we wanted to. And there we go. We're going to be influencing this in the construction script. We'll get in our Niagara particle components, and we will set the vector parameter for the end position, and we'll make a variable for that in a moment. And then we'll also set a integer parameter that we had made. And actually, let's see, I called it end pos, so for end position. So we actually want to copy that name over exactly, because it's important that these names match exactly. And the same thing here for spawn count. We're going to copy the display name, and we'll paste that in here as the parameter that we want to be setting. Now, we have a variable tab here. Let's make a variable for the end position. And that will, of course, then be a vector. We can just plug that into the vector end position. That's as easy as that. We'll set the default value for it to the same, so 200, 0, 0. But now we actually want this vector to also drive the spawn count, because the issue that we have right at this moment is if we like compile this, that's very, very nice. If we make this very long, we still have the same spawn count, and we kind of lose all of the detail that we had in our laser. And if we make it very like squashed down, all of those spawn counts are going to like do this, which also doesn't look that good. So the longer our length is here, the higher our spawn counts need to be as well. And that is easy to set up, because the easiest way to do that is we can just get our vector, get the vector length out of that. And then you can divide that by a number to make it more reasonable. In my case, I used 3. and that will then go into here, which will be truncated, meaning that it's only going to be using everything before the decimal, and that will set the spawn count. And as easily as that, now if we go into the end position and we do set this to like 20,000, we still have all of that detail all the way across, because it's now spawning in a frankly ridiculous amount of particles. And that is pretty much all there is to it. Now, the only thing we have to do is in the end position variable, we'll actually make sure that the typo is fixed there. We want to expose that, make that public. But then when we've made that public, we can also show 3D widgets for a vector and things like transform variables. You can show 3D widgets, which are useful if you're using a vector specifically for a position offset kind of thing. Because now if we drag that into the level, you can see we have this widget here and it will update like that. Now, one last thing that I want to talk about is the fact that you probably want to collapse this into a function real quick. So we can say collapse into function update laser particle, because now we can also use this in our event graph if we wanted to on begin play, do a timeline or something like that, right? Which then updates the position. You can animate this through code that way, and you can just reuse this update laser particle function however you want. We're not going to be doing that because, again, this is a particle video. This is a particle tutorial course, not a coding course. So you can figure that out on your own, or watch my other tutorials to learn more about that as you go along. And now we have the particle system from the beginning of the video, more or less, right? Wherever we put this end position is where this laser is going to be aiming. The impact particles, the little sparks, will always follow accordingly as well. So that's been the entire particle introductory course. Again, there could be an entire future course going over the more intermediate stuff instead of setting everything up in these module details panels. For some things, you just kind of maybe want to make your own modules. We can dive into that in a follow-up series. For now, I think you've gotten the tools out of this series to start playing about with particle systems, start experimenting, start making some fun little things. And maybe in the future, we can expand on that a little bit more. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sergey Thomas,